All right, here they want us to solve the following system. So we have three equations. Well, notice they already give us the solution to z. So all we have to do is we have to plug that back in to this one, solve for y. Once we have that, we plug that back in and solve for x. And so that's what we're going to do. So we got z is 5 in this one, so we plug it into the one before, like I said, and we take our 5 over and divide by 4, and we end up with y equals 3. So now we've got z is 5, y is 3, plug those into the first equation, and when we do that, we can say, okay, we'll take our 5 over, take the 15 over, and then divide by 2, and as we work our way down, then we find out x is equal to 2. Now, they gives us x is 2, y is 3, z is 5, and so that is our ordered pair. Now, they don't show the check here, but what we would really do is we would go back in and we would check. We'd plug each of those into all three equations. Well, z is 5. Well, we already have that one, so we know that works. Now, if we plug in the 3, 4 times 3 is 12, minus 5 is going to be 7, so that works. And if we plug it in here, 2 times 2 is 4, minus 15, and then plus 6. And so that's going to be 4 plus 5 is 9, minus 15, well, that's minus 6, and so it works there as well. So they sometimes leave out the checks in the book and things like that, but really that check is a very important key to knowing that you do have the correct answer. All right, so solving the system in three equations. First, eliminate one variable such as x from the two of the equations. Then use the two resulting equations in two variables to eliminate one of the other variables such as y. And then we solve for the final variable, which is going to be z. And again, it doesn't matter which order we do it. Maybe it's going to be easier to first solve for z, and then after that we can solve for y, and then after that we can solve for x. It really doesn't matter the order. Whatever looks easiest to do is how you do it. And then basically you substitute whatever variable you found first into the previous one of the equations and solve for the other variable. And then you take and solve and plug those two that you know into the first equation. And then you solve and you get your system of equations, x, y, z. And then again, I added the last step here, check your solution in all three original equations. They left this out, but this is really a key step. And so in the book, it doesn't always show this. And so that's the really the one to make sure you know you have the right solution, because you can work your way down and get a wrong solution. You plug in a variable and one of the equations wrong, and you get the wrong variable, which then causes another one to be wrong. And so that always is a key step, is step 5. All right, so we want to solve this system of equations, and so what they say to do first is eliminate our x. And so what we're going to do is eliminate x. And so the easiest way to do that is let's eliminate it in one of these by changing a sign. Well, let's change the sign in this equation, and then we add it to this one. And when we do that, we get minus 3y minus 5z equals 3. And then we can also take a minus 3 times the top equation, add it to the bottom equation. And when we do that, we see we have minus 3 times the top one plus, I guess they're doing the second equation. You could do second or third, it doesn't matter really. And then you take and you get this. And so now we've got this equation and this equation. Now, what they say is to take and look at these. I would say the best way to do is multiply this equation by 2, because then 2 times this is going to be a negative 10, and that's going to be easier to do. And then I just take, okay, well, that's going to be minus 6 plus 7, that's going to be a y, and then 2 times that's going to be 6 plus 3, that's going to be 9, so I get y equals 9 right away. But they think it's better to multiply this equation by a 7, this equation by a 3, and what they want to do is eliminate y's first. So they're always showing a lot of the ways get rid of the x, then get rid of the y, and then solve for z. But this one, I think it's easier to solve for y first. So that's kind of a key thing to think about. Might be easier to do a different way than what the book is showing. And in fact, I would have probably eliminated the y's first, and then after that, see what falls out after that. But again, it all depends on how you're thinking on how to do these. So there's multiple ways to do it as a key to think about here. And then when you add these together, you get minus 5 is equal to 30, and so z is 6. Now we can plug that back into one of these equations. It doesn't matter which one. And when you do that, guess what? We get y is 9, which is what I got right away. And if I would have got y is 9 here, then I could have said, okay, well, now let's solve for z right away. And I wouldn't have had to do all this extra work multiplying by 7 and by 3. I would just have the y straight away. All right, so that gave us y is 9, z is -6. So now we have to solve for x. Plugging that in, we go and we get x is equal to 3. Now again, they just go say, yep, that's the answer. Really, I would say go back in and check, plug it into each equation to make sure you've done it right. I have checked this; it does check out correctly, and so you don't have to worry about that. But again, when you're doing your assignments, I would always suggest going in and doing that check. All right, let's stop there, and we'll come back for some more.